My name is Evan Dameron. I'm a senior computer science student here at UK, and I'm an intern at the Center for Applied AI.
My name is Zach Bernard. I am a software development intern and AI researcher at the Center for Applied Artificial Intelligence here at the University of Kentucky.
My primary role here has been to work on the Temi robot, which is a commercially available robot designed to navigate and interact with users in an indoor environment. So Temi uses a combination of sensor data and computer vision to create a 3D map of its environment, and then can use path planning and navigation algorithms to move around between various waypoints.
On the Temi robot itself, you have the upper half, which is going to be an Android tablet. On this tablet there are various cameras, there's a depth sensor as well. On the base of Temi you have a LiDAR sensor that helps him estimate his position within his environment, as well as the moving parts, his wheels, and a few other sensors that help him navigate. Beyond his LiDAR sensors, his wheels, his cameras, and microphones, he also has a custom Java library that comes with the robot. This allows us to build custom applications on top of his current software. That way we can get a lot more technical and really customize it for our use case. For example, we use the cameras that are on him to be able to stream video to a server. On that server, we're able to perform computer vision algorithms on the video stream to be able to detect if a person within his field of view has fallen or not.
So in that case, if Temi sees a patient laying on the floor, it can immediately alert the staff and reduce the time it takes to get that person help. Right now we have Temi up and running in the office as a greeter and a guide. So Temi can automatically detect visitors as they enter the office and ask them if they need help finding any location. And if so, then Temi has all these stored locations and it'll escort that visitor to wherever they need to go. Temi is also equipped with a smell sensor, which allows him to patrol rooms and see if there's any odors indicating bad hygiene, like if a patient soiled their bed or anything like that, so that nurses and hospital staff can intervene as soon as possible.
Currently, Temi will leave his charging station at 8 a.m. every day and report to his working location, which is at the front of our office. He then begins streaming video to our backend server. The backend server then performs the computer vision. He does this all throughout the day. He will run through the office and take some smell readings, and then at the end of the day he returns to a charging station where he will then send out a report to whoever's on the email list of his findings that day. So that will include the number of falls that he has seen, as well as the number of smells that he has smelled that day, and the number of connections that the robot has had to the server.
If Temi is operating in a hospital or nursing home environment, then you'd want Temi to be able to take natural language requests and give natural answers. So to do that, we can connect it with the LLM factory, which can be customized to have specific information about that hospital or nursing home. I'd like to see the LLM act as the actual brain of Temi, so that it can decide on a sequence of actions to execute more complicated tasks. This would allow Temi to reason through complicated requests or tasks that it's never seen before, and then actually be dynamic so that it could view what's in its environment and then make decisions based on that. In our current approach with the state machine, we have to programmatically define each of these rules, but in complicated environments, that's not possible to account for everything. So we're trying to integrate the large language models so that we can allow Temi to adapt and make his own plans.
I would like to see Temi autonomously patrol an area. It's really fun watching him learn his surroundings and be able to navigate around different obstacles. I think as our smell detection gets even better and as our fall detection gets even better, he will become much greater at performing the tasks that we have for him today. The more data we get, the better he will be at those tasks. One major challenge is working within the limitations of the hardware on Temi. It is just an Android tablet, so it's having to handle all of the heavy lifting. Beyond that, getting Temi and the server connected, handling that handshake, getting the video back and forth, as well as the data that might need to be reported from Temi to the server was a challenge in and of itself. Beyond that, creating reliable fall detection systems that are lightweight enough to be able to run on Temi as well as the server but also give us reliable outcomes. Was definitely not easy.
As better and more capable autonomous robots, including humanoids, become available in the next couple years, the framework we have for decision making with Temi is going to easily apply to those, giving us a head start. I'm grateful for the chance to work on a project that's going to pave the way to see these autonomous robots deployed en masse in the next few years.